to Dr. Amrullah. I am Nur Amni binti Zulfikri. My metric number is 205381. So I will be the one who gonna start our presentation today for the ECC 3011 mathematics assignment. So we have choose inertia application. So what is inertia? Inertia is the tendency of an object to remain at rest or remain in a motion. However, from the Newton's first law of motions, it could define as a body at rest will remain at rest, and if in a motion will remain in a motion at a constant velocity, unless it acted on by a next external force, which is also known as law of inertia. The topic that our group chose for ECC 3011 assignment mathematics is moment of inertia, which is highly related to the concept of integration. As we know, inertia is an application that uses integration to determine the moment of inertia for area with curve about x-axis and y-axis. So, what is the main function of moment of inertia? Let me give you a brief about this concept. Actually, moment of inertia is used to analyze a body in rotation or in bending. For example, ruler. When we bend a ruler, it will be easy to bend when the white surface is horizontal, but it turns difficult when the ruler is oriented with a white side is vertical. Here we can clearly see that the moment of inertia much smaller when the width of the ruler is oriented horizontally than when it is oriented vertically. So we could conclude that the amount of deflection is inversely proportional to the moment of inertia of beam's cross-sectional area. Thus, high moment of inertia yield small deflection. That's all from me. Thank you. I will pass the button of presentation to Khairul to explain our main point of topic today, which is the moment of inertia area about y-axis.
Clap. Go.
Assalamualaikum and very good morning. My name is Muhammad Khairul bin Basri. Today I'm gonna talk about how to calculate moment of inertia for areas. Okay. So in this case, moment of inertia is rotating around the y-axis. And what is this? So this is the mass from the rectangle here, which is the head of the mass is y2 minus 1 and the width is z. Okay. So let's just go to the formula. Iy equal k from A to B as 2 times y2 minus 1 with z. So what is k? K is the mass per unit area. So each rectangle has mass of k times y2 minus 1 z. Okay. And we got another formula here. Ry equals square root of Iy over m. Ry is radius acceleration, meanwhile m is mass of the area. Okay, let's just jump into example. So we got example here. Okay, so for the first quadrant area bounded by the curve y equals 1 minus x2. So we're gonna find the Iy. This is the moment of inertia with respect to the y-axis, and m, mass of area m, mass of the area, and we're gonna find Ry, radius of direction. Okay, so first we're gonna look for A first, moment of inertia. Okay, before we do the calculation, we're gonna sketch the part of the curve with the equation that given before. Y equal 1 minus x2, and after sketch we got like this, and then as you can see, this is 0 and it's gonna represent A, and this 1 is gonna represent B. Okay, so this is all information we get. Y2 equal 1 minus x2, y1 equal to 0, A equal to 0, and B equal to 1. Okay, so we have many functions and we're gonna do the calculation next. Okay, so for the calculation, this is our formula before. Iy equal k is constant from a to integration from a to b x2 times y2 minus 1 with dx. Okay, after we substitute all the value, we got like this, and we're gonna do calculation a little bit, and we got x2 1 times 1 minus x2 dx integration from 0 to 1. K is the constant, so we can put it outside the integration. Okay, so after we times the x2 and x2 times 1 and x2 times x4, we got x2 minus x4. And then after that, we integrate, we got x2. After integration, we got x3 over 3, and x4, we got x5 over 5. Okay, and then we just gonna substitute the value, which is 1 and 0. So 1, we got 1 over 3, and minus 1 over 5. 0, we both got 0. Okay, so we got like this. Okay, 1 over 3 minus 1 over 5. And then we got 2 over 50. So we're gonna minus, gonna times 5 right here, times 5. And we got about 5 over 3 minus 1 over 5 over 50 minus 5 over 4. We're gonna times 3 here, times 3 here. We got 3 over 50. 5 minus 3, we got 2 over 50. Okay, so we times k, 2k over 50. Okay, next we gonna do the question B, which is mass of the area M. M equal k, where is the area? Okay, so we know that the area is equal from A to B, y dx, as shown from the formula here. Okay, so this is our information. Y2 equal 1 minus 2, from A equal to 0, B equal to 1. And we're gonna substitute the value in the formula. We got from integration from 0 to 1, 1 minus 2, 1 minus x2 get. After that, we integrate 1 become s, and x2 become s3 over 3. We're gonna substitute 1 and 0. We got 1 minus 1 over 3. 1 is power 3 minus 0. And then we're gonna minus it. Okay, so this one is times 3 over 3. We got 3 over 3 minus 1 over 3. So we got 2 over 3. Okay, so this is A, but we need to find the M. So as you can see right here, we have formula M equal Ka. So we got A, and we need to find M. But K is the constant, so we can just write K times 2 over 3. We got 2K over 3. Okay, so settle from the B. Next, we go from the C, which we need to find the radius of direction. Okay, so we got the formula Ry over square root of Iy over M. So this is Iy over 2K over 50 from question A, and M equal 2K over 3 from question B. Okay, so we can just put in the formula 2K over 50 is Iy, and 2K over 3 is M. Okay, we divide it. Okay, and we can times it, become like this. 2K over 50 times 3 over 2K. And we can just cut it and become 3 over 50. We can make the fraction smaller, become 1 over 5, square root 1 over 5. And then we calculate in the calculator, we got around 0.447. Okay, so what is GY? GY is okay, if the mass of 2K over 3 was placed 0.447, radius of gyration unit from the y-axis. The, would, this would have the same moment of inertia as the original shape. Okay, so that's all from my explanation about example. Thank you.
Clap. Go.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hafiz bin Muhammad Nafi, and I am going to explain about how to get inertia from the integration. So I am going to explain this by using an example. So we go to the example. So the example said that we need to find the moment of inertia and the radius of gyration for the area y equal to x square plus 1 from x equal to 1 to x equal to 2, and y is greater than 1 when rotate around the x-axis.
Go.
The mass per unit area is 3 kg per meter square. So for this question, we need to test the parabola first. So this is the parabola, and the shaded area is the part that rotating around the x-axis. So this is the shaded area, and there are two formula that we gonna use for this question. The first one is formula of moment of inertia, which is Ix equal to k constant integration from c to d y square multiplied by x2 minus x1 dy. And the second equation is equation of radius of gyration, which is Rx equal to square root of Ix over m. The Ix is the moment of inertia and m is the mass of area. So this question is rotating the area around the x-axis, and we need to express function in terms of y. So we solve the y equal to x square plus 1 to x equal to square root of y minus 1, as we need it as in terms of y. And we also have to take positive case only, as we dealing with the first quadrant. So the value that we gonna take is x2 equal to 2, x1 equal to square root of y minus 1, c equal to 1, d equal to 5, k equal to 3. So as we get all the value, we need to find the inertia, which is Ix. So we use the formula Ix equal to k integration from c to d y square multiplied by x2 minus x1 dy. So from this formula, we substitute the value that we already get, and it become Ix equal to 3 integration from 1 to 5 y square multiplied by 2 minus square root of y minus 1 dy. And for this equation, we substitute u to y minus 1, so we get du over dy equal to 1. As we get du over dy equal to 1, we know that dy equal to du, and y square is equal to u plus 1 square. This equation is we get from this, which is u is equal to y minus 1 and y is equal to u plus 1. So y square is equal to u plus 1 square. So from the value that we substitute it to the equation, this equation, so we get integration square root of u minus 2 multiplied by u plus 1 square du. So from this we expand and we get integration u power of 5 over 2 minus 2u square plus 2u power of 3 minus power of 3 over 2 minus 4u plus square root of u minus 2 du. And then we apply the linearity so that it will be more easier for us to solve the equation. So as we apply the linearity, we get this one, and we need it to solve it one by one. So the first one is integration of u power of 5 over 2 du. So from this we apply the power rule, which is integration of un du is equal to u n plus power of n plus 1 over n plus 1, with the n is equal to 5 over 2, and we get the v plus 1, we get the 7 over 2. So from this value we get the 2u power of 7 over 2 over 7. So the second one is integration of u square du. So we also apply the power rule and we get the u cube over 3. And the third one is integration of u power of 3 over 2 du, and we also apply the power rule with the n is equal to 3 over 2, and we get the value is 2u power of 5 over 2 over 5. And the fourth one is integration of u du. So we apply the power rule with n equal to 1, and we get u square over 2. And the next one is square root of integration square root of u du. We also apply the power rule with the n is equal to 1 over 2, and we get 2u power of 3 over 2 over 3. So the last one is integration 1 du. For this one we apply the constant rule and we get only u. So we plug in soft integral and it will become this one. And from this one we integrate one by one and we get 2u power of 7 over 2 over 7 minus 2u cube over 3 plus 4u power of 5 over 2 over 5 minus 2u square plus 2u power of 3 over 2 over 3 minus 2u. And from this we substitute back the substitution u equal to y minus 1, and we get this one. As we get this one, we plug in the soft integral and we get this one. For this one we need to multiply the k constant that we left at the beginning. So we get 6 multiplied by y minus 1 minus 6 multiplied by y minus 1 power of 7 over 2 over 7 plus 2 multiplied by y minus 1 cube minus 12 multiplied by y minus 1 power of 5 over 2 over 5 plus 6 multiplied by y minus 1 square minus 2 multiplied by y minus 1 power of 3 over 2. And we solve the problem and we get this one. And after that, we simplify it and it will become negative 2 multiplied by this one over 35 plus C. And for the next one, we substitute the limit into the integration, which is from 1 to 5. So we substitute it one by one, and the first one we get is negative 2 multiply this one over 35 minus by 2 multiply by this one over 35 also, and we solve it as we get the value which is negative 2 multiplied by 3544 minus 4375 over 35 minus negative 2 multiplied by 0 minus 35 over 35, and we solve it again and it will become 47, and it will become 47.485 minus 2, and we solve this and we get 45.48. So the answer for the finding Ix, which is inertia, is 45.5 kilogram m square. So the second thing that we need to do is to finding the mass of area, which is m. So we use the formula area is equal to integration from 1 to 2 x squared plus 1 dx minus 1. So we need to subtract the area of the 1 multiplied by 1 is equal to 1 square below the shaded area. So we get the value of this one, and we substitute the value of 2 and 1 and we get 8 over 3 plus 2 minus 1 over 3 plus 1 minus 1, and we solve the value and we get 7 over 3. So the area is 7 over 3. So from this value, m is equal to k multiplied by area. So 3 multiplied by area, which is 7 over 3, and we get 7 kilogram. And for the last one that we need to do is to find the radius of gyration. So the formula of radius of gyration is Rx equal to square root of Ix over m, which is Ix is inertia and m is the mass. So we substitute the value and we get the radius of gyration, which is 2.6 meter. Thank you for watching. I think that's all for me. So now I will pass to Shafika to explain about the discussion.
Go.
Hello everyone, so today I am Shafika. I will continue about the discussion part. So first, the application of integration in the moment of inertia. So first of all, I will define again the definition of the moment of inertia, which is the tendency of an object to resist a change. The formula is I equals to mr squared, which is I is equal to inertia and m is equal to mass R is equal to radius from the axis of rotation. So from here, we can see that the unit of the inertia must be in kilogram meter square. Okay, so actually, in order to calculate the moment of inertia for a rectangular object, we can use many other methods that have been uploaded at the Google, and we can use it as easily. But in order to get the moment of inertia for the irregular object, the area of the moment of inertia for the irregular object, we need to use the integration. Okay, so the moment of inertia for area, we can see here, if an area is bounded by the fx and also the gx. So here is the area where I shaded it out. Okay, we can see here, it is an irregular object, right? So if we want to compute this, we need to use the integration, which is the Riemann sum, which we will compute this in the form of integral. So let's say we have this area which is bounded by fx and gx, and then it will be given as the density of this area, so of this region area. So we can conclude that the density is equal to k, which is a constant. Okay, so density is actually equals to mass over area. I know before this, we always used to understand that the density is equal to mass over volume. But in this case, we can conclude that the density is equal to mass over area. So, in order to get the area of this, the area of the moment of inertia for this, we need to calculate using this equation, which is I equals to mr squared. So mass, how are we gonna take the mass? We're gonna take the mass by multiplying the mass of over area, which is density, with the area of this strip. Okay, first we need to calculate the area of this strip, which we can get from here, which is fx minus gx times with dx. So here, if we can see here, we already conclude it into the equation Iy, which is the moment of inertia about y-axis. Why it is y-axis? Because it is in the vertical, which is straight, vertical. The axis of rotation is in the vertical. So it is the moment of inertia about y-axis. If it is vertical, it will be about the x-axis. So the moment of inertia about the y-axis will be concluded as the integration of the from A to B. Okay, and then we conclude the K, which is the density, mass over area, times with the mass. Mass we can get from the strip. The mass of the strip, times the area. The area we can get from the strip. The area of the strip is fx minus gx times with dx. And then we can get x squared from the radius from the axis of rotation. Then we get the x squared dx. And then if we simplify it, it will become the moment of inertia about y-axis is equal to k, which is constant. We need to put outside of the integration to make it much more easier to calculate it. And then we can also compute x squared will be at the outside of it, and then we can get fx minus dx. Okay, now we are going to calculate about the radius of gyration of the moment of inertia for this area. So how we going to get the formula? The formula is actually can be obtained from the basic formula, which is I equals to mr squared. Okay, so here we can rearrange back, and then we can get that r is actually equals to third m over I. So then we can get the radius of the gyration. Okay, so for the last part is the moment of inertia about x-axis. Before this, we have explained about the moment of inertia about y-axis, right? We have explained how we get the formula. So now we are going to explain about the moment of inertia about x-axis, which is when the axis of rotation is in the vertical, such as like this. If you can see here, this is the shaded region, right? If we gonna take out or extract the strip, we can get the area of the strip is equals to Fy minus dy times with dy, which is here. Fy minus dy times with dy. And then we are going to calculate if we are going to multiply it with the radius of from the distance of the axis rotation, which is equal to y squared, from the limit of c to d. K is a constant like before. So the moment of inertia about x-axis is exactly the same like the moment of inertia about y-axis, but it is just different because it is in term of y. Before this, it is in term of x, but right now this is in term of y. So the next one is radius of gyration. The radius of gyration also use the same formula like before, which is square root inertia over mass. Okay, so the radius of gyration is actually when you have a mass, a total sum of mass, and then you put it at the distance of the same in the radius of gyration with the rotational axis, then you will get the same moment of inertia. So that's all from me. I'm going to pass my presentation to He Yu Yang. Thank you.
Name is He Yang, and this is my part of conclusion. So as a conclusion, moment of inertia is a calculation of the required force to rotate an object by using the application of an integral. The value can be manipulated to either increase or decrease the inertia. In sports such as ice skating, driving, and gymnastics, athletes are constantly changing their body configuration. By increasing the radius from the axis of rotation, the moment of inertia increases, thus slowing down the speed of rotation. Alternatively, if an athlete wants to increase the speed of rotation, then they must decrease the radius by bringing the segments of the body closer to the axis of rotation, thus decreasing the radius and moment of inertia. Thank you, that's my conclusion.